Welcome to Start Hacking APIs. Before we get going, please take a moment to appreciate this Jackson Pollock by a Stormtrooper. My name is Corey Ball. I'm the author of Hacking APIs, Senior Manager of Penetration Testing Consulting over at Moss Adams. I'm the founder of AppySec University and an OWASP API Security Top 10 contributor. Today, I'm going to be talking about why you should start hacking APIs. At a high level, APIs are a prevalent global business enabler. APIs are a leading attack vector by adversaries. And, as we'll see, organizations are overly confident in their API security. So, why APIs? APIs, this is an old factoid. They represent over 80% of all web traffic. And so these are applications communicating with each other. If data is the most valuable resource in the world, APIs are the pipeline that enable that data to flow. The global market for API management is predicted to be upwards of $41.5 billion in 2031. There are currently, as of 2022, over 46 million Postman collections available. That's a lot of APIs. And so I get asked occasionally, like, why not hoard this information? If you listen to the last talk, you'll have a pretty good idea of why, but we're outnumbered. There are enough APIs for everyone to test for the rest of their careers. Developers are providing APIs at an exponential rate that no one can keep up with. And so I like to speak to help enable people within their own organizations realize the risk of their APIs, which are a huge business enabler, and also enable the testers out there. This is Rapid API's State of the APIs annual report. More and more organizations of all sizes are depending on APIs. Orgs across the industries are depending on APIs, and API testing is a top priority, but not security testing. As you can see here, a vast majority are interested in leveraging APIs across all these different industries. API testing, very important. Yes, people are out there using tools that will help test for their APIs. A small percent doesn't know what API testing is. That's probably a little generous. And then when we get to the types of testing that people are interested in doing, it's mostly business and function related. And you see down below, security testing is at 4%, which is actually in a decline from the past year's rate, which was 4.5% were interested. And I need to speak more so that percentage can incrementally go up. So why are APIs a leading attack vector? And it comes down to the laziness of hackers, but also the time investment that goes into attacking and exploiting vulnerabilities at an organization. The classic hacking process, you have to find a way in, gain access into the internal environment, bypass all the firewalls, pivot around the network until you can find that sweet data, and then take command and control and find a way to exfiltrate that data. This is the MITRE kill chain. Explains that a little bit in more detail. This one highlight is where APIs come into play. It does exist on the MITRE kill chain, but it's sort of a blip. The hacking process with APIs, especially when they're internet facing, is that you find them and then you use them, and then more often than not, there's APIs that are available that don't require authentication, don't require authorization, dealing with all that sensitive data that you have to go through all that work to get into the network, bypass everything and exfiltrate. Instead, you could leverage an exposed API and just take the data from there. This next graph, it was made by a chief marketing officer, so it isn't that simple, but it does get the point across. The API testing methodology that I leverage, you still have a minor version of the attack chain, so you're discovering that there are APIs in existence. You're finding how those APIs are documented. APIs as a business enabler, they're meant to be consumed, and so documentation is out there to help developers consume the APIs of others. These could also be in the form of a Postman collection, and that just has all of the requests that an API has available for you to use. Then you're going to go through and use the API as it was designed. Make sure that you have the access that you need, credentials, tokens, your parameters are set up across the board, and then you can remove those parameters. So you want to go through, use it, make sure that you know what a good request looks like, make sure you understand the responses that are coming back. And then you're going to start taking away from that. So now that you know what it looks like by design, can you make those same requests for that sensitive data without authentication, without authorization? And then you can fuzz all the endpoints, send over random gibberish payloads. You can test the variety of API versions that are out there. Versioning is a pretty big problem for APIs specifically. Test a variety of request methods regardless of what the documentation says. Fuzz the post body parameters headers, and then exploit and prove your concept, report your findings. So these are a few examples of recent data breaches. Not to sling mud at everyone, there are all sorts of organizations that have had their APIs breached. T-Mobile had an unauthenticated, or an endpoint that didn't have any authorization controls in place, which led to 37 million instances of customer data that was exposed. Bumble, unsecured API endpoints, no authorization, lacking authentication, incremental IDs. Those were all leveraged in order to gather the data on 100 million users. And Optus, which we will talk more about in a minute, had very similar issues. No restrictions on how many requests could be made, and lacking authorization and authentication controls. And so attacker was able to take advantage of that in a very unique way. They stole all the data using the API, and then they threatened the company for a ransom. And this is one of the largest data breaches in Australian history. And so they called back. They had 10 million instances of user data, and they said, pay us $1 million or we're going to start leaking it out. 1,000 instances per hour or something like that, until either they were paid or the data was leaked. So diving more into Optus, we need to figure out what's going on with the confusion between organizations that are investing in their layered defense. They're putting a lot of money into protecting their organization, but somehow data breaches, specifically over APIs, keep happening. So experts say this data breach was one of the worst in Australian history. The Optus chief executive called it a sophisticated attack. But the Australian cybersecurity minister gets on Twitter and says it was not a sophisticated attack. We should not have telecommunications providers in this country that have effectively left the window open for data to be stolen. Then the chief executive responds, we have multiple layers of protection. They have a budget dedicated to their security, but something is happening. And in these cases, I think both sides are mostly correct. Once the endpoint is discovered for how the data was stolen, it's like learning the magic trick. Now you know how it works, not as impressive, not as sophisticated. The attacker uses an endpoint, no authentication or authorization is required, and so Claire O'Neill is correct in saying, not a sophisticated attack once you know how it works. The chief executive is also correct. She's putting a likely large budget into security. They have a layered defense, and they're confident in their security, but they don't know why. In this, No Name is an API vendor, API security vendor. They did a survey in 2022. 71% of respondents report confidence in their API protection. 67 are confident in their vulnerability scanning tools that are capable of testing APIs, very important air quotes. Meanwhile, 76% experienced an API security incident in the last year. These things don't add up. So what's going on? The common web app tools and techniques do not work for APIs. They give you clean reports that are amazing for compliance. We scan these API endpoints. We got our report back clean, no vulnerabilities. So, what we're seeing here, false negatives, one of the most dangerous things in all of cybersecurity for an organization to have. Tools that they're using to test out attack vectors that don't get quality results back. And I don't know if you can see this or not, but these are those common tools at their worst. No authentication, no authorization. Point it at the API endpoints and click run. We have no issues. But what am I scanning? I'm scanning deliberately vulnerable APIs, APIs that are meant for CTFs. They have all of the top 10 most common vulnerabilities. Scanners are okay at finding one of the top 10, security misconfigurations. So you can see here, Burp Suite, Zap, Nikto, they don't work and for APIs, and this is them at their worst. One second. Okay, so what about those scanners at their best? So now I've authenticated to a deliberately vulnerable application with a bunch of vulnerable endpoints. I've proxied all of the traffic to these tools. And I get back more results because we get past the front gate of authentication. The scanner without that is just going to hit that front gate and say, oh, there's nothing else here. I just get 400s for everything else, and it's going to stop scanning. So you can get a valid account, go beyond that, run your scans, and you'll get more results. And so there's some interesting findings here, but nothing that has to do with the API endpoints. The most you see here, something like clickjacking, you're going to see security misconfigurations. The key responsibility of enterprise vulnerability management is to make sure that the tools that they are using are sufficiently testing their attack surface. So I do really appreciate these tools. I use them. They're great for a step one But once you've gone past that, there are specific tools and techniques that are required for APIs that are unique. And that's why they get their own top 10 list. It's not because they're special in some other way. It's because they require a specific set of testing. API vulnerabilities for hackers, these are the things that I look for. Typically, all things are led from information disclosure. APIs are meant to be consumed by end users, so they need to be friendly so that you can keep, they're self-service so that you can fix it yourself. So it needs to have information disclosures in response messages that are friendly enough for the end user to fix it, but not too friendly where an attacker could take advantage of it. Outside of that, authorization is all over the place as far as vulnerabilities for APIs. Can user A interact with user B's information? Can they get that information? Can they alter it? Can they delete it? They shouldn't be able to. We lock this down on web apps, but APIs run in the background. They're not in the GUI. They're not on the browser. Maybe that has something to do with it. But these authorization vulnerabilities are all over the place. Once you're authenticated in some environments, there's no limit to what you can do. Authentication is the next issue. So one of the things that we do during testing when we're doing an API pen test is that we'll go through, like I said, use the API as it was intended, and you just remove the token. Click of a button, you can use Postman collection runner, remove your authentication, and run through all of those requests. So it'll make each request that makes up the API. And now you can observe, okay, a 200 was a good response when I was authenticated. Are there any requests for sensitive data that are still 200 once the authentication is gone? And oftentimes with vulnerable APIs that have all sorts of other issues, this is just the cherry on top. And outside of that, more authorization vulnerabilities. This is a new one on the top 10 that just came out in March 2023, BOPLA. It's a combination of two old items, excessive data exposure and improper assets management. That's not correct. Excessive data exposure is one of them. Mass assignment is the other. So, excessive data exposure. What happens is the developer sends across the full data object, and they're counting on the client to filter out that data and only give the consumer what they need. The problem is, if you proxy that request, it doesn't really matter what's happening on the front end because you just have the HTTP request from the API provider. And you get that full data object. So then you can learn new things about users. A classic example would be like a community forum where a whole bunch of users are adding their anger to this forum. But when you get the mass assignment request for that, it reveals that with each user, you can see their username, user ID, email, multi-factor status, whether or not they're an admin, all those juicy details that help in additional attacks. Mass assignment is the ability to alter properties that you should not be able to. Classic example of this is a user registration page. Normally, the front end is collecting username and password, but there is a way that an admin could also be created. And so you intercept the request, you add is admin equals true, and if that's the way things are set up, you become the admin just like that. Improper inventory management. APIs, especially web APIs, depend a lot on versioning. This is often done in the URL path. So you could see v1, v2, v3. You can also see environments in there. So UAT, you could see private, mobile, all these different things. And the idea here is a vulnerability exists if an unsupported version of the API still is out there exposed to consumers. And so if version 1 of the API had a SQL injection vulnerability, but that was patched in later versions. So now you're on V3. You can just, if V1 was not shut down, maybe it's there for some legacy requests, then an attacker could go fuzz the URL for other versions and discover that V1 is actually still available. Then they can go to GitHub, see the issues, and see that there was a SQL injection issue in V1. Hey, V1 is still available. Now I can continue my attack with SQL injection. Security misconfigurations. I already talked about mass assignment. Skip that. Security misconfigurations. These are all the classic unpatched servers, unpatched software, missing headers, so on and so forth. These scanners are good at that one. None of the others. Server-side request forgery. We see these more and more. An API is leveraged to request an image. It uses a URL in the request, and there aren't controls in place to prevent an attacker from making that URL anything they want. And so you can do some fun things with that. If an organization is vulnerable, you can actually use that as a reconnaissance tool to make requests to other devices that are inside the network where the web server sits. In addition to that, you can also force it to request resources from a malicious endpoint that you own and control. And so you can imagine possibilities with that. Business logic flaws. Are there ways that the API is designed to where no one in the design process considered, hey, how could this be used against us? How could this feature be used to attack us? And finally, lack of rate limiting. APIs have a cost per request, fairly insignificant when there's one. But when you get into other items, in addition to costs, you have things like how many requests should be made for authentication. So if there aren't other controls in place for a password reset where a 6-digit code is supplied, then can a brute force attack be done using the API? And if the rate limiting is very high, you can just send thousands of requests over, guess the token eventually, and gain access. Enterprise vulnerability management tools do find the security misconfigurations. Sometimes they can detect authentication issues, rarely. Information disclosure, you'll see some of those. Hey, this is an interesting response that you should go and check out more. And some SSRF requests, but they do miss all of the other items I discussed. So what needs to happen? We need to test the gaps. So authorized API testing has to take place. You can leverage those tools that are awesome at what they do. Burp Suite is my personal favorite tool, and I like to build out my API collection in Postman, proxy all of those requests over to Burp Suite, and then pinpoint and attack those. Between the two tools, Postman isn't, just in case anyone doesn't know, it's an API browser, so it works really well with managing all of the requests that an API has, all the endpoints, helps you organize it, helps you keep your parameters and variables organized. Postman is great for testing wide across an API. So if you wanted to test every single request of an API, which if you have 100 endpoints and each one of those has 5 requests, that could be a lot of requests that you're attacking over in Burp Suite. In Postman, there's a collection runner which will run through each of the individual requests and test out for things like improper assets management, or if you wanted to fuzz a variable in a certain parameter across the board. Great for doing that. For authorized testing, I like to get all of those requests over into Burp Suite and then go back through and look for resource IDs. If I find a request that will obtain a valuable resource or important sensitive data, then I get curious and I collect other resource IDs and replace it with others to see if I can gather passports or healthcare information or anything like that, which there should be authorization controls in place that don't allow me to do that, but often they are missing. API authentication, this could be anything from weak passwords, bad password policies, stuff we thought may have been taken care of on the front end in the browser, but once it got to APIs, it's back. And so can you make a very weak password? Are there lockouts for guessing multiple times? GraphQL is interesting. It's a query language for APIs. And instead of making a bunch of requests, you can make a single request for all the resources that you want. So one of the things that you could do with that, if there are no depth restrictions, is you can put every password you want to with every username you want to, send over a single request and see what sticks. So in order to manage that, you have to restrict the depth on GraphQL APIs to make sure that only one username and password is used at a time. I'm going to run through some of these because we're short on time. Use the API and then use it maliciously. One of the parts of this talk, I used to, at this portion, say, during the design phase, you need to have someone that has a black hat or a tiny black hat that can consider the API from an adversarial perspective just for a moment. I don't think anyone listened, so now you don't even have to do that. You can use ChatGPT, and you can just use this prompt, and you stick the API endpoints in there, and it will do it for you. And so you don't need your developers doing that. Just stick this into ChatGPT and see what comes out. And this is an instance where I put in the entire Reddit API, and I asked it to, the Reddit API has 200 endpoints. Out of all 200 of these, instead of me testing through all of those thousands of requests and figuring things out, which of these endpoints is the most interesting for an attacker and why? And provide me the top 3. And so you get through all of that work, and then you can go and check and see what's vulnerable. Summary, again, of why you should hack APIs first. Earn confidence in your API security. Do not have that false sense of confidence that's so dangerous, that leads to so many data breaches. Earn it. Test your APIs with the right tools and techniques. Go beyond your generic scans. Don't accept them when they come back clean, and finally you're going to pass PCI because you have no vulnerabilities. Question it to the PCI assessors. Don't accept those. Happy hacking, everyone. These are courses that are at AppySec University. These are all completely free. We've also just released 2 certifications. One is Certified API Security Analyst, and the other is the API Security Certified Professional. The ASCP is a 12-hour hands-on hacking lab where you have to test 2 vulnerable applications that are API-driven and find all the vulnerabilities within that time. Here's the QR code for AppySec University if you want to check that out. In addition to this, at 1 o'clock, we'll be doing Moss Adams-sponsored Hacking APIs giveaway. And so we're giving away somewhere around 45 to 50 copies of Hacking APIs. I'll be down there at the Moss Adams booth signing those at 1. That's it. Hope you enjoyed it.